Okay, the last session of the day. I'll try and keep it quick and to the point. Lift and escalator management systems, requirements and implementation. A little history, why I'm interested in this, and of course you thought I was going to talk about management systems, but I can't talk about lift management systems without talking about traffic, because obviously that's what I'm interested in. So if we go back to 1992, which was when I met Luke for the first time, you're looking very surprised. You were very young and very enthusiastic. In fact, you were younger than this slide here. And actually, that was the first time I met Mary-Lisa. Where's Mary-Lisa? She's around as well. Yes, that was when we first met Mary-Lisa in Amsterdam at a conference. And a very excited Ludwig bounded up to me and said, can you read this paper? And I found a kindred spirit in about someone else who was really excited about traffic analysis. And he was talking about something called the inverse SP method. And I've mentioned this a couple of times. Lutfi's ideas often spark other ideas, and I was excited about this. And what he was basically saying is when we're doing traffic analysis, we can take up-peak passenger demand, and then we can calculate, using the traditional formula, the number of stops that the lift is going to make in pure up-peak. And of course, if we know the number of stops, then possibly we could work out what the passenger demand is. Not actually counting people, but there is a relationship between the number of stops and the up-peak passenger demand. And he demonstrated this with a graph. Do you remember this? Wow, yes. I'm still studying your papers from 1992. And so that was a really interesting thing for me. And I was doing, Lutfi, who was at the time would have been Gina's PhD student, I think. Yeah. Yes, absolutely. So they were very concentrating on up-peak and down-peak calculations at the time, where I was doing general analysis, which basically mixed traffic up and down. And I thought, actually, I could apply this idea to try to work out the number of people just based on stops, passenger demand. And I did do a little bit of work on it, and I presented some of that in 1996. It was really interesting. I was really excited about it, but my problem was I couldn't get traffic data out of lift controllers. You can see where I'm leading now. I couldn't get the data to do any more research on it. Yeah? So that was my problem. And I know, without looking at Lufty, he's now thinking, oh, I could do this Monte Carlo simulation. Yes? I bet you could, yes. Okay, so Monte Carlo simulation, of course, you could use it for this. We should talk about that. I was sort of a bit of an activist then, and I then presented a paper, this is in the 90s, still about remote monitoring and the need for it. And what we want, actually is what I wanted, but I've tried to generalise it into what we want, is lift monitoring, where we can actually just get this data, get access to this data, and I gave lots of reasons why, as a consultant, I'd also want it. Yeah, I mean, I wanted it as a researcher because I wanted this number of stops, I could do some research. And basically I was saying that we want open remote monitoring systems with a standard protocol, better integration with building management systems, yeah, so we can monitor a range of installations. We can have a single monitoring system. It doesn't matter whose lift it is. It's all standard. And then we can do performance analysis based on the same objective measures. And that would be really, really interesting, wouldn't it? If we could get access to that data. And I wasn't the first person to suggest that, because I think in 1990, Gina, you produced a standard, suggested standard. So I'm always finishing off what Gina started, as I tend to do. And my example that I showed, well, I'm a musician, some people will know, and in the musician's world, you have something called MIDI. And this is an Ensoniq ESQ1 keyboard, which was my first really cool keyboard, very, very powerful. And this is also a piano module. One's made by Ensoniq and one's made by Yamaha, but they both speak to each other very well, because there's a musical instrument digital interface, and it's a standard interface. Yeah? So it doesn't matter whose equipment it is, it talks to each other. Very useful. Wouldn't it be really nice if we could have one of those on a lift? And again, that was something that Gina suggested some time ago. We want to be able to go into the lift motor room, plug in our standard interface, and we can pick up all of the information that we're interested in. I couldn't get anywhere with that at the time, so it went to the back of my mind, though it came up again when I was working with Rory Smith, who's over here, when we were doing lift monitoring as a result of trying to demonstrate the consistency of simulation versus the real systems in destination control. So basically, We built the dispatcher and we were logging every single thing that went in and out of the dispatcher, which is an enormous amount of information. And we were doing it on this lovely big building. I've got that there because that was in 2008. We presented that in Greece. Nice places we go for these conferences sometimes, isn't it? Yeah, and then we were looking at this building here, which is quite a big building, and basically I was taking the information out of the TAC50 controller, continuous 24/7, 365 logging, plugging into my simulation software, running it again. This is the traffic collected, so we had lots of information, and this is what Rory is referring to. Actually, at dinner last night when we talked about traffic signatures. Yeah, this is 5 days worth of traffic in the same building, and it's all consistent. It's like a signature. And then we were able to put it into the simulation and able to demonstrate that the simulated, so the logging results, this is the logging and this is the simulation, and you can show that they're consistent, and simulation and real world matches up, let alone round trip time calculations and simulation. We can close the loop and do simulation in real world, which is good. So that's my background. I'm sort of a geeky person who's really interested in traffic, and I want information out of lifts, and that's why I'm interested in monitoring systems. Some of the lessons that we learnt, or gathering this data, company IT networks managers are increasingly nervous about opening ports and stuff to let us communicate to the internet. So I find that we want to go onto it, we put information out of the lift, we want to then plug in the internet and actually upload data, and people are very nervous about that. Lift maintenance companies and their personnel quite reasonably, and I put that in as a concession, quite reasonably are nervous about the client having such detailed information about their performance in keeping the lifts operating and responding quickly to problems. We've actually found, several instances I've come across a lot of opposition because this is the spy in the cap. We talked about GDPR. We know, if we do this, we know exactly what's going on as a client, as a researcher, and that's sometimes not in everyone's interests. Interesting, lifts can incorrectly report they're in service when they're not. So I had a whole number of instances where the lifts said they were working fine, the controller and the dispatcher all thought it was working fine, but actually they weren't. So sometimes faults aren't reported by the controllers. And the other thing we found was that building owners and property managers are really interested in this data, and insurance companies as well are interested in this data, as well as researchers and lift companies. So there's a lot of people really interested in this data. And because of that, of course, you have lots of different monitoring systems available from the lift companies. And I've just shown the majors here, but obviously there are a lot of independent systems as well. So I came to the point where, sort of, how can we take this forward? And it made more sense to actually come from the client point of view, from the lift company point of view. And I started working with building owners and property managers because they're really interested in unified monitoring systems. All these individual systems are great. If you've got an estate where you have an Otis system, a Kony system, a Schindler system, a ThyssenKrupp system, etc., etc., what you really want is one unified system, something that talks to each other. And from the client perspective, they don't necessarily need to know that the door lock on the 3rd floor is not working properly. They don't need that level of detail. They want things like, they want to be messaged if something goes wrong. If something goes wrong, they need to get an email or a text or something like that. And they might want to know if it's going to a special mode. So if you are going into car top control, for instance, if it's being put on a preference service, that sort of thing they need to know. They want to be able to see where the lifts are and the door operation, so you can see the lifts going up and down and door operation, so they're able to see that on their phone or their tablet. And they want to be able to respond to a phone call or something saying the lift's broken. So they want to be able to go and see without walking half a mile to find out whether actually that's true, whether someone's reporting something real or actually the lifts are working. So they want to be able to test it. And they also want historical data. For instance, what percentage of the time has this lift been in service in the last year? It was 95% when you first installed it, and it's been maintained by a different company now. Is it now still 95% or is it 75%? So actually that data is really interesting to building owners. So with that as a sort of overarching brief, we developed Actually, I didn't develop it. It was Jim Nickerson, who's got a picture down here, because he's far more intelligent at this sort of thing than I am, but built this interface. So this interface will interface by CAN, Ethernet, RS-232.485, so pretty well anything that you can do. And if you, with the right interface, in one instance we're picking up, we just started getting the data from 30 lifts with just one board. Yeah, so we can pick up an enormous amount of data if we have the right digital interface that's provided. Sometimes we don't get that and we have to use relays. So this is just for one lift, expensive solution. Got to get output relays from the controller, and then you take the inputs and lots of relays clicking, not always as reliable as a digital interface. So we've done lots of installations like that. We're also found it was interesting that the lift indicator people knew most of the information we wanted to know. So they actually know floor position. Often they know whether the doors are open or closed. They sometimes know when the lift's out of service. So a lot of that information is available to them. And if they've already got a serial interface with the lift controller, we can interface with them. So we can pick up. And this is two examples. The left-hand side is Drews Grove, and the other one is CE Electronics. So we built interfaces to both of those. So what we're finding is we're building all these different interfaces, which is taking time, but it is possible to do. And then, of course, these days we've talked about the IoT. We will continue talking about IoT, and all you actually need is a card and an internet connection. If you've got a digital interface, one card, one lead, internet connection, and it goes up to the cloud, and then you can access the information from there. So I really want digital interfaces. Digital interfaces make it really easy. Once we've designed them, they work. Not relay-based interfaces. So the card is configured locally. One of the things we learned, of course, is that we want to, when we're developing new interfaces, then you have to keep updating software. And I used to spend a lot of time in the middle of the night working to update software, and to be able to do that remotely is something that we developed, so we could do that. Currently, someone in San Diego is updating an interface which is in London, and they can just download the latest software. We then provide an animation of the lifts. So this is showing these two lifts are working, they're in normal mode, and showing the location of the lift and the door status. And the buttons at the bottom are means to insert calls on the top landing and the bottom landing. So the specification required was from my iPhone or whatever, I want to be able to actually put in a call in and insert a call and get the car to move. And the bottom button is the reinsert to door reopen. So individually we've got there lifts and escalators, and then we have a schematic showing the status of a whole building's worth of elevators and escalators. And of course, going back to my geeky traffic analysis interest, now we have lots of data, lots and lots of lovely data. We like data, and now we can have a number of every instance we've logged. Yeah, how many door reopens, recycles, what stops there are. And that's basically a log of just a short period this morning of this particular lift. This was going up and down and recording each of those instances. And that's the data now that we can put back into our traffic analysis and estimate the demand. Yeah. I think does that answer the question from Mary-Lisa this morning?
Yes.
Sort of.
Yes, sort of.
Sort of, yes, okay. So lessons learned in gathering data. Every supplier offers a different interface. I'm going to say that, you can challenge it if you like, but in our experience, every supplier, lift controller manufacturer, lift company, we have to have a different interface, unless it's a relay-based interface. For building owners and operators, and that, if possible, specify this stuff right up front, because if you try and retrofit it, it is very expensive. And I think Anna mentioned this morning sort of quotes thousands of pounds just to put the necessary outputs on a lift controller, just to get sort of about 6 or 7 outputs and 3 or 4 inputs. If it's a relay-based interface, it's expensive. So getting inputs and outputs can be expensive, and hence Anna's paper from this morning accelerometers. That's interesting, isn't it? Because a lot of that data we can get from an accelerometer rather than get inputs and output from the controller. So that's why we're interested in these generating spatial plots. One of the reasons we're interested in generating spatial plots from accelerometer data. Of course, you can do a lot more with accelerometer data. So there are lots of different ways to interface with lifts. Some are really cheap, some are really expensive. Wouldn't it be really nice if you had some standards? Back to my MIDI interface from 25 years ago, whatever it was. Wish we could just plug into something standard. And I'm actually quite excited about the paper Rory's going to give tomorrow about what they're doing in China, where they basically tell everyone this is the interface we're going to use. We can't do that in a democracy, but it's an interesting solution, and perhaps that's going to help me enormously in interfacing with lifts. So some final thoughts as you stand up, Len. Yeah. Cloud-based monitoring is coming, and it will become standard. Whether or not you like it or not, it's going to become standard, and every lift is going to be connected, and we're going to know everything. For a lift company, we're going to know everything that you're doing. Yeah. And that's going to be really useful information for clients. Different people want different inputs and outputs. So, in fact, in Gina's original standard, you had 3 levels of inputs. Some were interested to the client, all the way to the ones that are interesting to me and Lutfi for doing research and extrapolation and so on. And it will highlight companies and personnel who deliver good service, and vice versa, which is why it's a little bit dangerous, and why I make myself unpopular sometimes. But we are wasting a lot of effort and time if we don't standardise our interfaces. So this is what we need to do, in my humble